All right. First, I share the screen correctly. All right, I will just try to share the presentation in a slightly different way. So, all right. Okay, so I believe the presentation is now visible. Sorry for the delay. Hello, everyone. My name is Dmitro Shuba. I work in a platform team at HSBC. So I work on Android releases, CI/CD, and mobile infrastructure for our Android applications. Today we'll talk about how to set up Android UI testing on CI. So the agenda for the day will look like this. We have 5 items. The first two will be about the CI itself, so the integration with CI tools and preparing the Android environment. And the second part of the talk will be dedicated more to the Android UI tests and their performance optimization, how we can run them and where we can also run them. Um, this will be a very packed talk. We have only 20 minutes, and I'll do my best to make it as informative as possible. So get ready. Okay, so the first section is integration with CI tools. Just to mention that CI is intended to verify, test, scan, analyze your project as the code is written. So the automation of the UI test might look different in different CI tools. There are CI tools that are more mobile focused, such as Bitrise or AppSent or AppCircle, and they might make your life easier with setting up UI tests in there. You can also use other CI tools as well. Uh, Most of them will not really give you any restrictions on how you can run UI testing. So, and it's also if that's a common set tool, it's also easy to find any materials and how to run them there as well. Um, as for the UI test on the CI, adding this stage to your pipelines, it consists of 2 steps. The first one is the running of the Android system, either in real device or emulator, or maybe in Docker. And the second part is executing the tests themselves. So I also would like to mention about the process as well, about the how exactly we run them and what we run the pipelines. So besides just executing the tests and preparing the environment for it, just want to give you an example. So let's say we have 500 tests and each runs in 2 seconds. In total, it will take at least 70 minutes just for the UI test and also the assembly of the build. Now, the question is, would you rather add it to a pull request or a nightly build? So I think the question itself, which is, it's often the way the question looks like this when we are trying to integrate UI tests in RCI, but I think that the question is wrong because we also need to think of what exactly we run and what is sometimes more important and how, because by excluding the UI tests that we can skip in some of the pipelines, we can definitely improve the performance, but just not doing the job that we don't have to. So what I want to highlight here is that we can, if we were to include the UI testing stage to the pull request, for example, we can only execute heavy scenarios or execute the tests by their size of the suite or this, of the tests themselves, their how heavy they are with the native filters such as small test or media test. We can also try to detect which UI tests if we are likely affected and just try to run them instead. There are multiple ways, but what I want to highlight here is that we can exclude some of the UI tests from executing, and this is why sometimes what is more important than how exactly we run them. The preparing of Android environment is a necessary step for the UI testing. In an Android environment, we first need a project code base where we will be able to build app and test APKs, which are required for the UI testing. Alternatively, though, we can try to provide app and test APKs straight away if we already have them, because the APKs themselves is what UI tests really need to be able to run this use in it. Other than that, we also need the Android platform. An Android platform consists of the Android SDK, which provides you all the utilities that you might require for launching Android system and the project itself. You also need um, the build system itself. So the vast majority will just use Gradle. So the Gradle will need Java, for example, and this is also something that needs to be on the CI at this point. And the device prerequisites as well. So the place where you actually run the Android system. Now, device is a very interesting topic because it's quite extensive, and this is a separate question, separate section as well. So devices, emulators, and Docker is the options that we currently have, the most common options that we have for running UI. And the UI tests, they require an Android system, which can be found in real devices, emulators, or Docker. Now, when it comes to use real devices on ACI, you need to understand that it's at scale, so you probably don't need 5 devices, but more like 10 or 20, and it means building your own device farm in-house. Just want to highlight here that it's quite a tricky task because building your own device farm in-house for real devices is very demanding, as real devices, they require particular temperature, humidity, the room conditions must be followed, so the devices are well kept, and it's like keeping the servers. Very similar conditions should be followed. Other than that, it's quite expensive to build and maintain, so the engineering costs might be very high for creating your own solution. And also real devices may break as well. Their physical issues may occur to them, battery swelling or ADB disconnect if the wire is not good, anything can happen to it. Now, emulators on the other hand, they also have their own drawbacks as well. They cannot emulate specific devices, and then of the day they are not a real environment, they're not a real device, but emulators for CI is great because they are fast, cheap, and emulators scale really, really well. So emulators is what is actually used by the majority of the companies, I believe, and the majority of the products use emulators because they scale well and they are easier to configure and launch as well. Now, the last but not least, is Docker containers is also an option because Docker got more adopted and more open source solutions got released. Um, However, Docker containers are efficient and scale even better. They are much harder to set up, and there are less materials available on how to set them up. As I mentioned, some open source solutions are available. So I'd like just to mention here that there is a repository, Android emulators container scripts by Google, which provides many, many instructions on how to actually run an Android system straight into Docker directly without any system in the middle. Uh, there are also solutions that let you run Android system in an emulator in a Docker as well. It's slightly different, but the first one provides you an ability to run Android system directly in Docker container. What is common among all these ways of running Android system is that Android system is an Android image, and we need it to be specified to be able to understand what we run. An Android image needs an API level, which is an Android version, a device type, a TV or wireless or a phone, and Android binary interface, which is the specification of what CPU the Android image is targeting, format x86 a bit more further. And also we need to specify other features, such as if we need Play Store, if it's an indicator is also needed to be included. With the SDK manager, when creating an Android image or just requesting what images are available, an image would look in the end something like this. So you can see that the specified API level, the device type, the CPU that is targeted, the architecture ARM or x86, and things like that. So also, when you have the system image of the Android, you can run it on a real device. But what you can also do is run them on the devices that are provided by the other services. So this is just honorable mentions of some of the services that can provide you access to their own device infrastructure. They can provide you access to emulators or real devices as well. So Firebase Test Lab, AWS Device Farm, Samsung Remote Test Lab is just one of those that you can use to maybe replace some of the parts of the infrastructure in your system, or maybe just to use real devices that they provide instead of setting up real devices farm for you. They can be reasonable when it comes to some very particular tests, such as performance tests, for example. Now, test execution and optimization is very interesting because, well, there are quite a few problems with UI tests that go apart from the CI. The UI tests are slow, they are flaky, and they are hard to profile. So let's first start with how to make tests fast. First thing that you can do is to improve and optimize the emulator itself. We mentioned there are two CPUs that Android system can target. ARM is more common in real devices. It has lower power consumption, but x86 is very, very fast, even though it requires nested virtualization. And when running emulators on cloud, you need to look into some instructions how to enable this feature in the cloud provider that you use. But overall, target x86 because UI tests run faster there. Other than that, you can disable unused features. So with ADB, for example, you can disable all the animations in the system along with some other features such as spell checker, for example. In configuration of the emulator of the device, you can disable the sensors that you don't need. And also, you can also disable the emulator UI with the bash parameters when launching the emulator itself. You can also see in the example that you can also disable the camera, the front and back cameras as well this way. But why would we want to disable the emulator UI, the emulator view itself, the emulator window? Is because on the CI, we do not need to see how the test is executed there particularly, uh, because the graphics will be still rendered for the test itself, for the application. And when recording the test via some Gradle plugin or some other tools, you'll be able to still see how the test scenario is going, but you don't need the window of the UI of the emulator itself on the CI to do those things, and it will definitely decrease the amount of resources used. Now, from a test perspective, don't use thread sleep, and instead you can use other resources in smart weight in your tests. Instead of running tests sequentially, you can run them in parallel, or you can use test sharding, which allows you to run a suite, for example, that would take an hour on a single device. You can split them into two subsuits and run them on two devices, so it would spend half an hour approximately, for example. And you can use real network requests, but you can also mock them, and that can also improve the speed of the test, as you don't need to wait for the real response from a server. Making tests stable is also a thing, because to make them actually stable, what you need is, it's preferred to run the UI tests in isolation, so they do not have anything from the previous ones, from previous tests, and all the tests start with a clear state of the application itself. You can clear the state of the application manually, but it's not recommended because it's not a very reliable way. Instead, I recommend using the default native test instrumentation runner argument, clear package data, set this value to true, and it will clear the package data of your application with each run of the test, which will provide isolation for it. Another way is to apply a retry strategy. Some UI tests are flaky because identification may just appear in the application above the application, or a system pop-up, for example, will show in the middle of the server scenario. It will break the test sometimes, and instead of failing the entire suite or entire build, you can just try to run the tests that are failing, and that can also help. Now, making your test more clear from login perspective, to make it easier to debug UI tests and actually see the problems that may occur, the issues that happen to it. What tests can additionally include the screenshots of the scenario and also the video of the execution. Along with that, network requests log can also be provided, along with more extensive test reports. So all these small details can make debugging of UI tests much, much easier. So this is why I really recommend to try to include as many of those artifacts as possible, to make the login easier and tracking the issues much more faster process. Okay, now the test runners is something I'd like to mention separately, because test runners can solve the issues that we mentioned before. As by default, the test runner is used as Android JUnit 4. However, we also have custom solutions, custom test runners such as Marathon, Flag, Spoon, Fork, many of those. I just want to highlight two of them. Marathon test runner, for example, already provides you with some functionality that lets you do the test sharding, some split execution of test use across multiple devices. It also gives you ability to have more extensive test reports with more details, screenshots and videos execution, the flakiness strategy, smart retries, along with device pooling and test filtering. So all the issues that I mentioned before can be fixed with some of the tools here as well. And you will not need to implement all these features on your own to fix the flakiness or the slowness or other drawbacks of the tests. These can be provided by the test run itself. Another test runner that I can also mention is the Frank. It also provides test sharding, and it also gives ability to run stability tests. However, it also lets you use their device infrastructure instead of setting up your own one. So it's a more basic test runner, but it allows you to use their device infrastructure instead of providing them your own one, which can also save time. Now, the summary of that section. So as for the CI, um, think about what you run sometimes instead of how you run it, because uh, in many pipelines, UI tests can be configured in a way that we exclude some of the suits, some of the sets, so it will not be so it will save on the resources that we use for this run, and it will simply make the UI test more reasonable to actually have it in a particular pipeline. Also, when testing UI, remember that what is needed is the Android SDK, build system, and the prerequisites to it, and the device itself where you will run the Android system. It can be an emulator, a real device, or Docker. Emulators are fast, they're cheap and easy to integrate, so they're quite easy to start with, and I would definitely recommend this option as well. Now, other than that, prefer x86 Android systems because they run faster and then also improve the performance of the UI tests for you. As for the tests, I would recommend disabling features that the app doesn't use, which could be sensors, animations, cameras, whatever is not used in the application. You will not use the resources for supporting these features if you disable them in the first place. A short UI tests execution across multiple devices because it can save the build duration, and launching the test suite across several devices can speed up the processing of the entire suite apparently. um, Use idle resources in smart ways for UI. As for network, you can mock the API so you don't have to wait for a real response and you don't have to wait for the server to respond to you. um, Run UI tests in isolation and apply retry if they're flaky to improve their stability. Now, also try to add video screenshots of the execution for better feedback so you better understand why UI tests are actually failing. And the last but not least, experiment with the test runners because they can already provide you the features and functionality that can solve the UI test issues along with some of the problems that might occur on the CI side as well. So they can definitely simplify your life, and that means. And that's it. Thank you all for listening this very packed talk. Follow me on Twitter if you want to learn more about the UI test. I post there announcements of the future talks I will make and also some of the other activities. Read more of my materials on the website dmytroshchuba.com, which is my personal engineering blog. And if you have any questions, feel free to ask them in the chat. I'll be happy to answer them.